In this video, we're going to show you a number of common RF connectors and cables, and we'll explain some of the differences between them. The first one we're going to show you is the N-male connector. So this is the male side of the N connector. That's what that looks like. And the female side is that. So that's the N female. The next connector is a very common one, the BNC. This is the female side of the BNC. And then this is the male side of the BNC. Now we have the professional version of a BNC. It's like a BNC except it screws on. More often used in GSM type telephony, cellular. But it's a very good connector, very more robust, I suppose, because it doesn't quick lock. It actually screws on and is very tight. So we have both the male and the female versions of this screw-on type of BNC. That's screw-on type. And that's the male or the female version of that same connector, the professional BNC. Now here's another common connector, the SMA. This is a male connector, low-powered connector, the male SMA. And then here is the female version of the SMA connector. Now we go to the SMB connector, which is similar to the SMA, except that it is a snap connector. It's often used internal to equipment as opposed to external, because obviously if it can snap on, it can snap off pretty easily. So it's not very rugged for external installation. And then there's another connector, also commonly used, an SMC connector. And this is also available in a screw-on version. And then we move to the 7/16 DIN connector, often used on the output of 1 kilowatt transmitters. There's the male and there's the female. 7/16 DIN, good for about 1 kilowatt. The flange type connectors. This is a 7/8 inch EIA flange. Interesting thing about these EIA flange connectors is that the inner conductor, which you will see, is removable. Thus, every connector can be a male or a female, depending on whether that flange is installed, or the center connector rather is installed, the inner. One thing that's very important to understand about these flange connectors is, as you can see, when you mate them together, the center conductor goes first. And if you've got any possibility for RF or static or anything else on the outsides, there's a potential for shock and or damage to equipment. So it's always good practice to connect a wire or a screw through those connectors. Don't let any static or other potential go through you. Don't put your right hand on one and your left hand on the other. You could get a jolt. So always try to short the outsides, that is the ground shields, together before you mate them. Same thing is true with the 1 5/8, which we'll see here, the 1 5/8 flange. That's for higher power. Note that the 1 5/8 is good to about 15 kilowatts. This is the 1 5/8. There's the center conductor. Same warning about the inner. It mates before the outer shell, the shield. So make sure you ground the outside shields before connecting this thing together. So the 7/8 is good for about 5 kilowatts. The 716 DIN is good to about 1 kilowatt. And you can count on a BNC for about 100 watt. Now all of these wattages assume FM frequencies. It would be somewhat less at higher frequencies than the FM band. Now looking at cables, we have two types and two variations of those two types. There's approximately a 1/4 inch size cables, which are RG58 or RG223. The difference is the single shield or the double shield. In general, we recommend always using a double shield, not just because of the shielding effects, but because it makes the wire, the cable, far more robust. It's much easier to have a robust, a firm connection to the connector, and you'll get longer life out of a cable that has a double shield, like this one here. Often used in instrumentation, these BNCs and 1/4 inch cable, RG223 recommended. Then we have also the 1/2 inch version of this same situation, the RG213 and the RG214, the difference being whether it's single shield or double shield. There's the roughly 1/2 inch version, often used for a little bit higher power, and again, the double shield is much more often preferred than the single shield version. The BNC connector is very common. You can see one here used in instrumentation, a professional type of connector. It has a crimp-on connector underneath there, and it is very robust, usually used for instrumentation or low power RF, less than 100 watts or so. Now we can see the sleeve that goes along the outside of this connector, adding considerably to the robustness of the BNC connector. You can see the sleeve there. That does work very, very well to protect the cable and the connector against breakage, particularly when it's being manipulated. This is a different kind of BNC connector that's just a clamp type rather than the crimp type that we saw before. Not as robust, but suitable for permanent installations. Now let's look at the higher power cables that are used for fixed installations, typically for transmitters and fixed installations of receivers. There's multiple brands that are used here. Cellflex is one, Flexwell is another, Heliax, which is from Andrew Corporation, is another brand that's often encountered. The first we're seeing here is a 1/2 inch, and this connector is a Cellflex. The insulation is foam. These are closed foam cells, so there's no need for pressurization. This 1/2 inch cable is good for about 2 kilowatts. There's the center conductor in the 1/2 inch cable. There are several brands of this 1/2 inch here. All of these cables are semi-rigid and are not designed to be flexed much. If you flex them multiple times, they will break. This is a less common 5/8 inch shield or outer conductor only. It's not often used, and we'll not talk about it too much. Next up is a 7/8 inch Cellflex rather. This is good for about 5 kilowatts. There's a foam version, and then there's also a 7/8 inch air-filled, which is a spiral insulator internally. That has less loss, but the downside is that it has you do have to pressurize it, and pressurization can be expensive, and it can require maintenance over a period of time. So that's called a Flexwell, and all of these that we're looking at right now are 50 ohm cables. All the cables we've seen to date so far are 50 ohm cables. So that's what a Flexwell looks like: spiral air insulator, lower loss, but you do have to pressurize it to avoid there being condensation internally and leading to a failure over time. Now this is a higher power 15 kilowatt capability, 1 5/8" cable, also 50 ohms. This is Cell-Flex. And so you'll see when we look in the end that it's filled with a closed foam. No pressurization is necessary because there's no way moisture can get in between the center conductor and the outer conductor. So that's a 1 5/8" 50 ohm Cell-Flex, and there's the flange that would be typically used for that. Typically, the flanges go with the same size of cable. However, there are a number of flanges that have different capabilities. So you might have a 1 5/8" flange for a transmitter that's got that output, but you only use a 7/8", for instance, cable, or vice versa. There's a number of different variations, and it's always good to make sure that the manufacturer of the connector is the same as the manufacturer of the cable, because not all companies' cables fit the connectors of a different company. Lastly, we're going to look at one more kind of connector, which is kind of on the line between consumer electronics and professional electronics. This is a 75 ohm F connector, and you'll often see this as a receiver type of cable, the input to a translator, the input to a receiver, but it's 75 ohms. It's also using a low loss foam. It is a crimp type connector. It wouldn't be used in most cases for any kind of transmission, but it's often used for the inputs to televisions or FM receivers, very low power. Be very careful that the center conductor, again, makes with the connector before the shield, and therefore there's the opportunity for damage to your equipment or even shock hazard to yourself if you're holding on to two things and you haven't shorted the shield of the F connector to the female side as well. So this is what we wanted to try to present today, a selection of common cables and connectors. Certainly not encyclopedic. It doesn't cover everything that's out there, but probably covers about 99% of things you're likely to encounter in your work in broadcast engineering. Thanks for watching.